Niels Bohr first proposed the first successful model of the hydrogen atom in 1913. It was a simple planetary model, like the Earth orbiting around the Sun, as shown here. Instead, a light negative electron in a circular orbit around a heavy, nearly stationary positive proton is shown. Instead of a gravitational force, an attractive electric force holds the electron in its orbit. In order for the model to work, Bohr had to make a radical proposal. The electron can only occupy certain stable orbits with prescribed energies. This screen shows that the electron can occupy several different orbits, but is never found in between. This is what is meant when we say the electron is quantized. More properly, each specific orbit determines a specific energy for the electron, so it is better to say the energy levels or energy of the electron are quantized. The next screen will explain that as the electron moves outwards, similar to the loop plane on this screen, the energy of the electron increases. Again, that screen just emphasized the increasing energy of the electron. The next screen will show specifically that the electron must absorb energy to make a jump up to a higher energy level. This energy may be in the form of light, heat, or electricity in general, but this simulation focuses on photons of light as the energy source. On the next screen, watch for a photon of light to hit the electron to excite it to a higher energy level. Here comes the photon. Note how the electron moved to a higher energy orbit. It had to absorb energy from the photon for this to happen. A very important generalization in science is that systems do not like to be in high energy states. In the next screens, you will see the electron spontaneously return to the lower energy state. To do this, it must release energy. Did you see the photon released as the electron lost energy? Watch as another photon comes in to excite the electron again. Did you notice that this photon was a different color and the electron got excited to a different level? On the next screen, you will see how photons of 4 different colors each have a different energy and are capable of exciting the electron to different energy levels. So here are the photons of different energy coming in, and each time the electron gets excited to a different energy level. Don't worry about the equation on this screen, but the idea that light of a certain color or wavelength carries a specific energy is important. The red photon you will soon see is low in energy. Note how the electron was only excited one level. Okay. On the next screen, the excited electron will lose energy and emit a photon. Okay. Did you see the red photon emitted? Okay. An electron falling from level 3 to level 2 must release the same amount of energy it absorbed to go up from level 2 to level 3. Each of those energies is represented by the red color photon. The next 2 screens will show what happens with a more energetic blue photon excites the electron. Here the electron absorbs a more energetic blue photon and goes up 2 energy levels. Okay. And now it releases a more energetic blue photon and therefore goes down 2 energy levels. The next 2 screens recap the 4 different transitions seen in this simulation, showing each first as absorbing photons of different wavelengths, then releasing the same respective photon from when the excited electrons lose energy. So here are the different absorptions from low energy to high energy. And now the reverse process is releasing photons from low energy to high energy. Okay. The final two screens will show that each different photon emitted will show up as a specific spectral line. These are the lines we saw on the spectroscope looking at the fluorescent lights. Each corresponds to the energy difference between two orbits and has a specific wavelength. Okay. Notice how the spectral lines are appearing each time a photon is emitted. Okay. There were 4 different photons emitted, and you see 4 different lines on the spectrum in the middle of the page. Okay. This slide reminds us that each of those lines, although we recognize it as a specific color, came from a specific energy and therefore has a specific wavelength. Note that excited electrons do not always exactly reverse their paths, as shown in this simulation. Okay. I will show another simulation which will show that an electron, when it's excited more than one energy level, may take different paths back to the lowest energy state, not just exactly the same path it took. So here's the second simulation. In this simulation, the electron starts in the lowest energy state, also called the ground state, and you can see it way at the left of the diagram with the electron in a circle right next to the proton that represents the nucleus. Okay. I will fire a photon to excite the electron to the 6th energy level, which is the outer ring. I will do this several times, and we should see different responses. Okay. So here comes the photon, and it excites the electron to the 6th energy level. Watching that electron, it's going to lose energy. In this case, it lost a lot of energy to energy level 2, and then it will lose some more energy to go to energy level 1. If I repeat the process, again, incoming photon exciting the electron to level 6, it's going to lose energy. This time it went straight back to level 1. And I'll do it even one more time. We're likely to see something even different. So excited to level 6. This time it went right back to the first energy level. Okay. I am going to do this a couple more times, but the next 2 times I want you to look at the energy level diagram in the upper right of the page. Right. This is an alternate method of visualizing the orbits or energy levels of the electrons. It is important to understand it represents the same model in a different way. But this is the model that we will use in an upcoming worksheet, since it is simpler than drawing the full orbits. Right. So keeping your eyes on the energy level diagram in the upper right, I'm going to excite the electron again. And you see the electron, the energy level diagram jumps up to level 6. Okay, this time it lost energy only down to level 3, and then down to level 1. If I repeat one more time, still look at the energy level diagram in the upper right. The electron moves from level 1 to level 6. It's going to lose some energy. This time again to level 3. And then to level 2. And now it will go to level 1. And I'll do it one last time. Okay, excite the electron to level 6. And this time it went first to level 4. Again, it's taking a different path each time, more or less. Now to level 3. And then it jumps down to level 1. Okay. That concludes the video. You can learn more about the Bohr model by playing with this simulation on your own, but you will need a computer that runs Flash to do it.